Whenever we talk about asymmetric encryption, there is what's called a keyed pair. And so these are mathematically related. Typically, we call them a public and private key. And so for us to be able to use, this is what typically is the most confusing thing for people to understand cryptography. For asymmetric encryption, we would use the keyed pair. But in order for us to do this, we need to make sure that we, at least at a high level, understand the why behind this. Because one of the things to remember here that I think helps to make this a little bit easier is that anybody who uses this crypto system would be part of the realm of trust, right? Remember that what I said before, that realm of trust, the quote unquote realm of trust. So that realm of trust, it means that the user has been enrolled and verified in the software, because there's software that's running all of this stuff here. And I say that because once you realize that this isn't voodoo, and it's actually ends up being what I usually draw here is an umbrella. You get put into, this is my silly way of calling an umbrella. You know what? I just crossed through my. But you basically get put underneath this umbrella, and when you get put underneath this umbrella, now you can actually send and receive things underneath this umbrella, which is kind of cool. But in order to do that, you have to be part of this realm of trust, right? And so why do I draw it like this? Well, the realm of trust in our for the software is kind of like the it's typically an X509 certificate authority, a CA, and you get enrolled into this software. Usually the easiest way to think about this is, in practice, is the global addressed list, the GAL. So if you're looking to send an email or go out and send a message, let's say in Slack, because you guys are using Slack, if you're looking to send an email or looking to send a message in Slack, if that user is within the realm of trust, right? They've been vetted, they're on your domain, they have a Georgia Tech email address, then they would be inside the realm of trust. And it's likely that we can look them up in the GAL. And so the GAL would be where their public key would be published. And so we could go out and actually look that up in the GAL. Okay, great question. So that stands for the global address list. GAL stands for global address list. So in Outlook, like you hit the to button and you start filtering it down by last name or first name, you can find that person in the GAL. And so that person's been vetted, they've been verified, it's claimed identity, and because of that, their public key is available in the GAL. So if I wanted to send them an encrypted email, so an encrypted message, for instance, I would use their public key. So I have the message, I'd go out, do a lookup in my key distribution center, which would be the GAL, and I get their public key, I run it through the algorithm, I send the ciphertext across the wire, and then the system behind the scenes here does some magic because of that's what the software does. It would actually figure out who the recipient is, send the message, and only allow the person that it was sent to actually decrypt it. So the recipient would then use their private key when they receive it, using the software to decrypt it. And it only works if there's a crypto system in place where everybody does this in the realm of trust. And so, there's a bunch of different vendors out there that use the same process or very similar software to be able to have everything allocated in a way that's meaningful. But usually this is the way that it works. And so the phallic way that I remember this, and because that's typically what people remember, is either I say a curse word, I say a joke, or I say something phallic. And so for this particular one, I'm gonna say only you can see your private parts. Only you. Right? So only you see your private parts. Why do I say that? Well, because if you show them to people, they're no longer private. I mean, what kind of show we running here? And so whenever you're talking about asymmetric encryption, once that private key is compromised, it's no longer private. And so you never give up your private key. Understanding this fundamentally is the key to your success. Because if we share the private keys, they're no longer private. And we have to use the crypto system in order to encrypt. We can't just willy-nilly use something and then you expect the other person to use something. They have to be in that realm of trust, which is typically through software. So that's usually how I explain it. I hope you understood it. And so for our purposes here, we talked about symmetric being n times n minus 1 over 2, whereas asymmetric would be 2n. So the number of keys with the number of users goes up. It's 2n, right? Because there's a private and a public key that is assigned to each individual user. And we call that a keyed pair. So it's a public and a private key. That's a keyed pair. And so it really makes sense that 2 times n is the way that we would figure that out.